match each function with its graph. So we have f double prime, and f prime. So we want to figure out which of these functions is the original function, which one is the derivative, and which one is the second derivative. So to do this, let's just think about some properties of how functions and their derivatives relate. So for instance, whenever a function has a minimum value or a maximum value, then what that means is the first derivative is equal to 0. Okay, so let's pick one. Let's assume that this right here is the original function, and this one here is the first derivative. Let's see if it matches up. So whenever the original function has a minimum or a maximum, so here and here, then what has to happen is the first derivative must be 0. So that means if we come down here, we should run into our first derivative being on the x-axis, which is exactly what's happening here. So that's pretty certain that we have the the original function and the first derivative correct, which would leave this one to be the second derivative. If you want to further make sure that this works out, we could say if the original function is concave up, then that means that the second derivative is greater than 0, and the original function is concave down whenever the second derivative is less than 0. So for instance, it looks like I am concave down on this interval here, and then I turn and I am concave up on this interval here. And the second derivative, this line, notice it's below the x-axis on this interval. So what that means is the second derivative is less than 0. So concave down, second derivative is less than 0. So that works out. So the solution here, the original function is the graph in green. The second derivative is the one in blue. And the first derivative is the one in red.